Hi everybody, this is David releasing the new feature for our restraining retaining wall, which is based on the application of vertical loads over the stem of the wall. So to check this new feature, you can go to the US menu and then go to our restrained basement retaining wall. Once you click on it, we are making awareness of this being a beta template. We're gonna click yes on it to be able to use it. And once we are here, you can see our restraining retaining wall. So what it's new is that we have added now in the social section the possibility to add both vertical dead and lift load. So we're gonna be adding a load of 1 pound per foot. Once we do this, this vertical load is now being considered inside of the design of the steam wall. As you can see now, we scroll down and see new calculations. For example, in the factor vertical loads for stability design section, you can find both vertical dead load and live load over the steam. And with this, we are considering both dead and live load in the design for restraining and bearing. As you can see here, we have the concentrated steam dead load, and in the lift load vertical load soil bearing, you can see here we have the steam live load. So you can either leave a load factor of 1 or change it according to your design necessities. As well, in the structural strength design loads, you can now see that we are considering in the vertical steam loads both dead and live load. And these load factors are going to depend on the loading that we are inputting. However, you can always override this value according to your necessities. After this, you can see that we are now adding two new sections. One is going to be the combined flexural and axial in the stem, as well as the axial in the stem. So as you can see here, we have different calculations to consider the interaction between both flexure and axial. And as you can see here at the bottom of the section, we have a note telling users that in this case the slenderness effects can be ignored. However, if we have a different case where the slenderness has to be considered, for example, if we have a wall with a greater length, you can now see that the slenderness effect has to be considered, and with that we are calculating the moment demand interaction for this. After this, also you can see in the axial in the steam section that we are now calculating the axial strength, and all these values are going to be summarized in our steam summary. So as you can see, now we have the actual demand of the steam wall as well as the actual capacity of the steam wall. Thank you so much. I hope you get the most profit of this feature, and let us know if you have any feedback on this. And it would be well appreciated. Thank you so much.